Okay, let's talk about where earthquakes happen from a global perspective. Earthquakes in general are going to happen along faults, along breaks in rocks along which motion has already occurred. And those faults, remember, they can be normal, they can be reverse, or they can be transform faults. You can have earthquakes that occur that accommodate some of any of these types of motion. Lots of times we think about earthquakes happening on these strike-slip faults, especially in the US, because we think about the San Andreas a lot. But they can happen along normal or reverse faults as well. Here's an example, once again, before that farmer had rebuilt his fence, you can see this is the same place that was imaged before, where this is the fault. This is the fence that was broken, and it was shifted 2.5 meters, so about 8 feet from one earthquake in 1906. The moment magnitude of this was approximately an 8. Which direction of motion occurred along this fault? Okay, well, we're standing on one side of the fault and we're looking across, and from our perspective, this fence shifted to the right. So this is a right lateral strike-slip fault. And over time, it's these earthquakes over and over again that are actually causing the motion along that fault on a geologic timescale. It's also motion that exists along thrust faults. That can be hard to tell what exactly the thrust fault is on this picture, right? But this was from 1964, the largest earthquake to occur on US territory, so a magnitude 9.2. It totally changed the morphology of this particular area along the Alaska coast. And this set of coastline actually moved upward about 6 meters. That's a lot of motion. Here's where the fault was, right? So this block here moved up and towards the shore along a fault that extends down into the ground, sort of in the direction that we're looking. In a global sense, where do earthquakes happen? Well, if you just plot all the earthquakes, you will get a very good idea of where the plate tectonic boundaries are on Earth, because most earthquakes happen along plate tectonic boundaries. So you can see the boundary of the African plate I've highlighted here, or the boundary between the North American and the Pacific plate there. Certainly around the Ring of Fire, which is split by this map, which includes all this area and all this area, that Ring of Fire is certainly very susceptible to earthquakes, just like it's susceptible to volcanoes. But you also get a whole lot of earthquakes on that continental convergence zone, where the Himalaya are up here, the Indian subcontinent colliding into the Eurasian plate. So you get a lot of earthquakes along there as well. And then through Iran and into Turkey as well. It's sort of into Central Eastern Europe even. So, if we're looking at this, a lot of times when we plot out the earthquakes, we will plot them in both different sizes, dots, and in different colors to emphasize the strength of some of these earthquakes. You can see there are a lot of small earthquakes that occur along many of these boundaries, but along the transform boundaries here and the convergent boundaries here is where you see that there are some of the very largest earthquakes happening. So, shallow earthquakes can occur at all types of plate boundaries. Deep earthquakes only occur at convergent boundaries, especially where oceanic crust is involved, because those earthquakes can occur in the subducting slab. Subducting slab being the one that's subducting. And as that drags along the mantle here, it's the asthenosphere. That drags along. That motion there can cause an earthquake that's very deep underground. Weak quakes can happen at all types of plate boundaries, convergent, divergent, or transform. But really strong earthquakes generally only occur at the transform and convergent boundaries. Divergent boundaries tend to not have very strong earthquakes because you're not dragging two solid tectonic plates together, you're pulling them apart. This just illustrates some of why that is, right? So at a divergent boundary, the faulting that's occurring is very near the surface and it's relatively weak because it's really only occurring in one plate, and it's not because the plates are pushing together, but because they're pulling apart. Whereas at a convergent boundary, with an oceanic plate subducting, you can have shallow earthquakes, you can have intermediate depth earthquakes, or you can have very deep earthquakes. And these can be weak or they can be very, very strong. It turns out that humans can also cause earthquakes to happen. There has been a recent increase in seismicity in Oklahoma. Oklahoma has no plate boundary, but there have been a lot of earthquakes recorded in just the last 13, 14 years or so at this point. Why have those started happening? Well, this coincides with when we have started injecting wastewater into the ground. So you're putting pressure, you're putting strain on the rocks because you're pushing water that's contaminated with drilling chemicals into the ground just to dispose of it. Don't recycle that water, it's too contaminated. So instead of spending the money to do that, we just drill a hole and we shove it in. But that strain builds up over time, and it has caused earthquakes up to a magnitude 5.8. Not huge, but not nothing if you live near these earthquakes. And some of these have caused thousands of dollars in damage. We're probably not going to be capable of causing a magnitude 9 earthquake like this, but we can cause small to intermediate ones just by disposing of our wastewater. And this is wastewater that comes from fracking. So that's where earthquakes happen, but when do earthquakes happen? Well, it's very hard for us to gauge exactly when they're going to happen, but the mechanism of rocks breaking means that the earthquakes only happen when the accumulated stress exceeds the strength of a rock at a point along that fault. At that point, the rock will break, and that breaking will propagate along the fault. So how can we predict that to some accuracy? Well, we can know that a strain accumulates over time. So that means that sections of faults without earthquakes for a long time are probably due at some point. Are they due this year? Are they due 10 years from now, 100 years from now? It's very hard to determine. Any closer than knowing that a particular section of fault is due, roughly, is currently not possible. There are some systems that we have set up to get warning to people that aren't right at the epicenter, but they really only give you seconds to minutes of warning, and it really only happens once a quake begins. It's much like you might get a tornado alert on your phone because a tornado has been spotted in your area. You would only get a warning about an earthquake happening right before it's about to hit you, giving you enough time to take some shelter or get to a safer location. Because that's all the prediction that we have, just the fact that the earthquake has already started.